Here's my fifth lab, Create Your Own Adventure. I decided to track and analyze the motion of the three-point shot. The goals of this experiment were to 1. Obtain real data from a video of a basketball player shooting a three-point shot, 2. Use Newton's second law to predict the motion in VPython of the basketball once out of the shooter's hand, and 3. To compare the experimental data versus the data predicted by the model in VPython. Here is the video in Tracker. As you can see, I tracked the center of the mass of the basketball from the shooter's hand until it reached the basket. After tracking the ball, it was important to find the initial velocity of the ball. I found it by using delta r over delta t, or the change in position over the change in time. The initial velocity is shown next to the red star. Other initial values are shown in the white box as well. They include a standard mass of the basketball, which is 28 grams, the starting position, which was 0, the starting time, which was 0, and the known value of g, which is 9.8. Newton's second law, V final equals V initial plus F net over m times delta t, was used to analyze the motion of the ball in VPython. We show that here at the bottom of the screen. It is necessary to also update the position of the ball in this VPython code. That equation is shown right below the code for the velocity. It's shown here. And it is based on the equation for the velocity. It is also necessary to account for all the forces acting on the basketball. Once the ball is out of the shooter's hand, the only forces acting on it are the weight force and the drag force. The weight force is Fg equals negative mass of the ball times g. We also have to multiply it by a vector because the weight force only acts in the y direction. So we have to multiply it by the vector 0, 1, 0. The drag force is the velocity squared times the coefficient, which is shown right here. And F net, of course, is the sum of all the forces. After inputting all of this into VPython, I ran my model and got this. Looks like a ball going into a hoop, right? I extracted the data from VPython and compared it to the experimental data I found in Tracker. The blue line shows the model and the red dots show the experiment. As you can see, the two graphs are very similar, indicating that the model input into the VPython was correct. Any errors in this experiment come mainly from erring in the tracking of the center of mass of the ball in Tracker. That concludes my experiment. Thanks for watching.